many shells does one atom of titanium have? So how many rings? Jacob? 4. Very good. Okay. Now, let's talk about how many electrons are on a shell. How many electrons are on the first shell in titanium? Chloe? 2. Good. 1, 2. Okay. Keep in mind, this black ring around the outside of the nucleus is not a shell. It's just showing you the outer edge of the nucleus. Okay. This pink part is the nucleus. The gray circles around it are the different rings. Okay. Now, how many protons are in one atom of copper? How many protons? So the positive particle inside the nucleus. Matthew?
Two things. 19.
Why 19?
Or 29.
29, because it says 29 up here. Okay.
And when are we gonna learn about atomic mass? Because you said that's the weird thing with the decimal.
It's coming up. It'll be in the notes tomorrow, I believe.
Because there's no atomic mass in the definition.
You are correct. Okay. How many protons are in one atom of titanium? Class?
22.
22, because the atomic number is 22. If there are 22 protons, how many electrons should it have? Class?
22.
22. Okay? All right. Moving on to compound. Maybe. Okay, compound. A compound is a pure substance made of 2 or more elements that have a fixed ratio. Now, once you write that down, I do want you to underline, circle, put a box around, highlight, put a star on it, something, the word element. Because this is key. A compound is a pure substance of 2 or more elements that have a fixed ratio. Okay, go ahead and write that down, and I'm going to explain it a little bit. Okay, the part about fixed ratio just means that there is always the same number of each atom. For example, carbon dioxide, that's what CO2 stands for. To make carbon dioxide, there is always 1 atom of carbon, 2 atoms of oxygen. Those numbers never change. Okay? Now, a couple things here as well. In the chemical formula, when you see the subscript or the small little 2 almost below it, okay, that 2 is talking about the symbol before it. So, if there is no symbol, or no number, sorry, there is an understood 1 right here. Okay? No one ever writes it, but there is no number, it's understood there is just 1 of them. Okay? So, for every molecule of carbon dioxide, you have 1 carbon atom and 2 oxygen atoms bonded together. Okay? 1 carbon atom, 2 oxygen atoms bonded together. You can't just randomly add on another carbon. Then you would no longer, first of all, it wouldn't work. Second of all, it would no longer be carbon dioxide. Does that make sense? Okay. That's what it means by fixed ratio. But the part about the element, okay? I want you to really emphasize this word in the definition because in just a minute we're going to write down the definition for molecule, which is very similar except for this word. Okay? So let me ask you this. If I have 1 atom of oxygen bonded to another atom of oxygen, is that a compound? No, it's not. Because I have 2 atoms bonded together, but they aren't different. It's the exact same atom. Therefore, it's not a compound. What if I had 1 atom of oxygen bonded to 1 atom of hydrogen? Would that be a compound? Yes, because I have a molecule of different elements. If I give you a lump of molecules and I say, hey, this is a compound, you would have to look at the atoms and say, do I have different kinds in here? If I do, you have a compound. If all of the atoms in that lump are the exact same element, you would not have a compound. Does that make sense?
Mm-hmm.
Okay. Now, keep that in mind because when we get to molecule in just a minute, it's going to be a little different. Jacob? Yeah, I guess so. Layla? Uh-huh. Does it have to be different to be a compound? Well, that's what we mean by two or more elements. That's why I had you highlight that. If you only have one element, it's not a compound. You have to have two or more. You could have 4, 5, 16, 25,000, doesn't matter. Okay? Aiden? Are there more different atoms in there? Yes. Each colored circle represents a different atom, therefore yes. There are actually three different elements in that compound, so yes, it's a compound. Okay? Yes.
So for the example thing, the CO2, I thought that stood for carbon dioxide.
It does.
So that means that that's two compounds of carbon dioxide?
No.
Is carbon dioxide an element?
This is a molecule. No, carbon dioxide is not an element. It's a combination of carbon and oxygen, which are both elements. This is one molecule. This substance is called carbon dioxide. But the elements that make it up are carbon and oxygen.
Oh.
Does that make sense?
So
it's like a recipe.
With the water molecule, would you still call it a molecule even though it's a compound because it's H2O, hydrogen 2, oxygen 1?
Because all you need for a molecule is to have two or more atoms. Doesn't matter what kind they are. They can be same, different.
They can be a compound atom?
Correct. Compound molecule.
That is correct.
Which we're going to get to in just a little bit. You're getting a little ahead of me. Okay? All right, next one, conductive. This should be a review, hopefully. Okay? Anything that has the property of being conductive has the ability to convey or transmit or kind of pass through things such as heat or electricity. Okay? We're going to use this term when talking about the kinds of elements that are metallic or they're metals. Gold, silver, copper, lead, titanium. Almost all metals are conductive. Now, there are some metals that are more conductive than others. What is the opposite of being a conductor, class?
Insulator.
An insulator. Good. An insulator would not convey things such as heat and electricity. Okay? Aiden? I suppose so, yeah. Okay? All right, next one. Ian, you good? Okay. All right, hold on. Actually, I want to skip this one for now. We'll come back to it. Go down to number 21, molecule. Okay? Because I want to explain molecule to you before I explain diatomic molecule. Okay? A molecule is when you have two or more atoms that are chemically combined. Basically, that are bonded together. Okay? So let me go back to my example for a second. If I have oxygen bonded to oxygen, we said that was not a compound, but look up here real quick. Is this a molecule?
Yes.
Raise your hand if you think yes, it is. It is two or more atoms that are combined. Raise your hand if you think no, it's not. Okay, good. This is tricky. Okay? This is not a compound because they're the same atom, but it is a molecule. Okay? All you have to check to see if it's a molecule is, do you have 2 atoms or 25,000 atoms bonded together? If so, it's a molecule. A molecule is much easier to make than a compound. Okay? Is this a molecule? Well, I have 1, 2, 3 atoms. Is that a molecule? Yes, it is. It also happens to be a compound because I have oxygen and hydrogen. Does that make sense? What about this one? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 atoms. Is that a molecule? Is it a compound? Yes. Because there are different kinds. Usually the different colors represent different atoms. Just like that. Does that make sense? Okay. Yes.
Technically, you can't have a compound You can't have a compound or you can all you can have is a molecule or a compound molecule. Because a compound is two atoms.
Correct.
Is two or more atoms that are different.
Correct.
But a molecule is two or more atoms.
Correct. Okay? Let me ask you this. What if you have one atom of oxygen bonded to one atom of hydrogen? Is that a molecule?
Yes.
Is that a compound?
Yes.
Yes, it is. What about this one? One atom of sodium bonded to one atom of chlorine. Is that a molecule?
Yes.
Is it a compound?
Yes.
Okay? Let me ask you this one. Is that a molecule?
Yes.
Is it a compound?
Yes.
Not bad.
Atom
Not
of carbon,
bad.
4 atoms
Okay.
of hydrogen.
What about this one? Is that a molecule?
No.
Why not? Manny? One atom. Very good. Does that make sense now?
Yes.
Good. All right. Now go back to molecule.
Wait, what?
What did I say? That's what I meant. Thank you. Diatomic molecule. Now, don't get confused. A diatomic molecule is just a special name for a molecule that only has two atoms. Oh, let me okay. A diatomic, this is the one that was not a molecule. Go ahead. The simplest molecules that contain only two atoms. For example, an oxygen molecule, oxygen gas is actually O2, two oxygens bonded together. It is a diatomic molecule because it is O2. Okay. If you remember we talked about bi in binomial nomenclature. How it means two, like two-name naming system. Okay. The di in diatomic is also means two. Okay. So it's a two-atom molecule. All right. So let's check. Is this one diatomic molecule? No. Is it a molecule at all? No. Is it a compound? No. So it's none of them. What about this guy? Is that a molecule?
Yes.
Is it a compound?
Yes.
Is it a diatomic molecule?
No.
No, it's not, because there are 5. This one, is it a molecule?
Yes.
Is it a compound?
No.
You said yes. Does it have 2 different elements? I'm being serious. Okay. Is it a diatomic molecule?
Yes.
Yes, because there are only 2. So it's a molecule and it's a diatomic molecule. This one, is it a molecule?
Yes.
Is it a compound?
Yes.
Is it diatomic?
Yes.
Is it a molecule?
Yes.
Is it a compound?
Yes.
Is it diatomic?
Yes.
You see, you kind of get how they all go together?
Yup.
Good. Connor?
So for dye, is it like in dye, like 2 or more of the dye?
I don't really know.
And also,
Maybe.
how I remember it, diatomic is it's on the diet, which makes it small.
There you go. That's funny. All right, next one. Formula. Yes, it's long, and yes, you have to write the whole thing. If you run out of space in the lines at the bottom, you will not use all those lines for symbol. Symbol's pretty short. So you can kind of draw an arrow and finish the definition down there.
Well, we have to write all of that?
Yep. Okay. The formula is the means to represent a compound. It is the way to write out the recipe for a compound. Okay? For example, this is calcium hydroxide. This is the recipe to get calcium hydroxide. You combine calcium, oxygen, and hydrogen. Okay? The formula is made by combining the symbols of the elements from which the compound is made with numbers that represent the ratio of each element within that compound. Basically, you have the symbols of the elements combined with the numbers of how many of that element there are. Matthew?
So a formula would be H2O equals the water molecule?
Correct. H2O is the formula for water. H2O2 is the formula for hydrogen peroxide.
What's hydrogen peroxide?
That's the stuff you, like your mom usually pours on like a cut that bubbles up and makes it burn and stuff like that. We also use it in the lab. I think to mix the yeast, maybe. The what? The foam, the elephant toothpaste? We use peroxide for that? I think we did, yes. It was the 30% one. Yeah. Yes.
I wrote really tiny. And I still have so much space left.
Nice job.
I can barely read it. But I can still read it. Barely.
Alright, let me give you a tip. Okay? Sometimes the formulas can be hard to read. Okay? The way that you tell what the different symbols are, okay, is each symbol starts with a capital letter. So, I'm going to put an example up here. This would never be a compound. Okay, this would never actually exist. But I'm going to use it to show you how to find the different symbols. Okay?
I don't even know. I have
Okay.
no idea.
A slew of letters, right? This is actually a bunch of symbols for different elements back there. The way you figure out which ones are which, every time there is a capital letter, it starts a new symbol. So look up here. 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 Turn around. Okay. Every time you have a capital letter, a new symbol starts. So capital B, lowercase r, that's a symbol. Capital F, that's a symbol. Capital O, that's a symbol. Capital H, that's a symbol. Capital C, lowercase l, that's a symbol. Capital T, lowercase I, that's a symbol. Capital A, lowercase g, that's a symbol. Capital K. Okay? Now, this looks like a capital I. If it were a capital I will write it like this. Okay? So, this is the symbol for bromine. This is the symbol for fluorine. This is the symbol for oxygen. This is hydrogen. This is chlorine. This is titanium. This is silver. This is potassium. Okay? But that's how you figure out where the symbols start and stop. Does that make sense? Now, a real formula will also have numbers thrown in there as well, but I'm just showing you that right now. Does that make sense? So this right here, this is actually two separate symbols. Excuse me? Great question. The parentheses mean that there are two of this molecule. Does that make sense? So the O and the H are bonded together. There's two of those bonded to one C. So that's what the parentheses mean. We won't actually get into that, but I'm just explaining to you. Correct. Correct. Okay? Alright, next one. Ductile. This should be a review, hopefully. Ductile is a property of some metals where they are capable of being drawn out into a wire or thread, like that duct tape I was telling you about. Okay, that should be a review, hopefully, from last unit. We will use it in this unit when talking about some of the metals, or that's at least it's a property of some metals. Okay, the next one should also be a review, malleable. Okay, Malleable. Capable of being extended or shaped by physical pressure. If you can shape it by squeezing or pressing on it, it is very malleable. If you cannot, it's not very malleable. Okay? My marker, not very malleable. I have to apply a lot of pressure to change its shape. The eraser, a little more malleable. Play-Doh, very malleable. But again, this is usually only used to talk about metals. We've also discussed before how gold is the most malleable metal, which is why they used to fight the metal. Yes.
So, oh yeah. So like how many sheet like so one sheet like isn't a sheet of copper like very thin?
Mhm.
Like how many how much copper would you need to make like a foot of wire? Like a few pounds?
I don't know. It's a good question.
Like if you wanted to make a wire that connected to the plug, like an extension cord,
Mhm.
and you want to use copper for it.
How much copper would you need?
Yeah, like you need a lot. You need like if you want to make like 10 feet, you need a lot of copper.
You might.
And like to make like 20 or 30 of them, more copper.
Mhm.
Way more.
Sophie? Are you missing some of the words? I'll just read it for you. Capable of being drawn out into wire or thread. Okay. Metal. A type of element that is a good conductor of heat and electricity. There are also other properties of metals, like they're usually shiny. They're usually somewhat soft to cut, depending on the kind of metal it is. Okay? But the main giveaway is they're good conductors of heat and electricity. Okay? Yes.
In that picture, are those long things tiny or are they big?
Are they tiny or are they big? You mean like long or big around this way? I don't know. Whatever you want it to be, I guess. All right, two more. I don't want to lose sleep in the desk. Non-metal. Oops. This one. Non-metal. A non-metal is an element that is typically a poor conductor of heat and electricity. I'll go ahead and tell you that the majority of the periodic table consists of metallic elements. Why don't you take your little lemon book and you can go over some of the questions from the last chapter. That might be good. Okay. Now, on the table, most of the non-metals are over on the right side. Okay, I'm going to show you. As I turn them around. All right. So, on the periodic table, over here, this is where most of the non-metals are. Okay? Now, just because they're non-metals does not mean that they have to be gases. Some of them are, some of them are not. For example, the one in the middle up there on the board, the red powder-looking stuff, that's actually phosphorus. It's right here. It's red phosphorus. Okay? That is a non-metal, but it's also a solid. Bromine is the one on the right. That's this one over here. Okay? Chlorine, the one on the left, is right here. Now, this is not the kind of chlorine that you put in your pool. This is a poisonous gas. Okay? Chlorine that you put in your pool is actually a compound of chlorine, mixed with other things but not chlorine.
That's what I think.
Okay? But most of the time the non-metals are over here. Okay? These are all metals. Except for hydrogen. All the rest is the metals. Okay? And then there are some that are like middle kind of metals, kind of not. Those are usually kind of right around this diagonal line. Okay? But we'll go over all those in the notes tomorrow. Yes.
So since gallium isn't metal, metals at a really low temperature, when you have a conductor, it gets hot.
Mm-hmm.
But so when it got hot, it would melt and then it would be a conductor.
Yes.
So it can conduct in a liquid state.
Yes. Just like water. Water is a conductor in a liquid state. How is gallium what?
Yeah,
Form? I don't know.
I mean, like, it can be metamorphic.
Well, I don't think you mean metamorphic. Metamorphic is like butterflies, caterpillars turning into butterflies.
It's something else.
That's right. Okay, last one. Symbol. Okay, we already wrote atomic symbol earlier, but this is basically the exact same thing. This is the alphabetical letter or letters used to represent an element and or a compound. We talked about yesterday how typically compounds are 1 or 2 letters. The only times I've ever seen them be 3 is as like a placeholder until they're officially named something else. Like unanoctium for 118. Now called oganescent. Just capital O, lowercase s. I don't know off the top of my head. But like the periodic table that I'm giving you in your notes tomorrow has all of those with their names. Not like mine. 117 is tennessine. TS. Okay? Brooklyn. Unanoctium. I guess they don't have to, but they like to, I guess. I don't know. Sometimes they name them after the person who discovered them, or the person who discovers them names them after something. Depends. Sometimes. Except it's not an element, but I guess so. Alright, Imee and then Matthew. That's what we're going to do next. Imee? I thought I would give it to you today. I forgot we had to finish the vocab. Tomorrow you will get it, though. I'm going to give you the rest of the notes tomorrow that will have the table in it. Was that what you were going to say? Okay,
No.
Matthew?
So I have